Okay.
Sure. I'll try and share my screen.
Yeah, we can see.
So you can see the presentation, right?
Yeah, just red rectangle and Gramine Buildpack.
Yeah, exactly. All right. So give me 1 second. Okay, I'll have to reorder that. Okay. Thanks for having me here at the Gramine contributor meeting. And of course, also thanks for the providing such a great tool. I think without it, many things in the SGX world would become much more difficult. So I want to say here really that I appreciate the work of the Gramine contributors. My name is Frida Paape. I'm the Chief Technology Officer of newly founded Convera Systems. Convera Systems aims to provide services and toolsets to facilitate trustless computing within confidential computing environments. Trustless in this case means that an unknown third party is able to completely attest and verify a client's enclave app down to the source code. And some very popular use cases here are blockchain oracles or blockchain bridges. They need to testify and verify to arbitrary third parties that they are actually doing what they should, what they're supposed to do. I started working on confidential computing related projects in 2000 with Madana. There I took part in developing a LibOS hosting system for the OVH marketplace, which was based on SGX LKL and Kubernetes. And since last year, I work as an advisor and consultant for Integrity. And with Integrity, I was asked to come up with a simple to use LibOS solution. And I did some comparisons, and I just basically, I think I thought Gramine would be the nicest LibOS to use because it's just already there for a long time and quite stable. And that solution should basically allow clients to integrate their use cases with Integrity's SGX blockchain. And that was basically how the Gramine Buildpack idea was born. So Gramine is known to all of us, but what is the Buildpack part that I'm talking about? Well, cloud native Buildpacks are an interpretation of the source to image concept. And this concept, this approach tries to fully automate the steps from turning arbitrary source code into an executable container image. The approach is in contrast to project build pipelines, which are often highly customized and complex. Not all projects can easily be converted to source to image projects. There might be things that are just way too complex, but often it's actually possible to just drop your source code into such a solution and it will convert it to a runnable image. From a very high level view, code is provided to a build image, which outputs the final image ready to be used. Again, Buildpacks are an interpretation of the source to image approach. And at the core of this approach, we have single Buildpacks. And their job is to gather everything your app needs to build and run. So it might provide, in this case, with Node.js, it might provide Node.js binaries. It might configure files for itself or other Buildpacks, and it will provide process entry points, which can be passed as startup arguments for the image. More than one build pack might be necessary to satisfy your app's dependencies. And this example, say there might be a Go application, a Go web application, but this Go web application needs to be compiled, but it also might be dependent of some front-end Node.js packages. So we have to add some build pack that downloads these JavaScript packages and configures them accordingly. Now, to combine multiple build packs, we need some sort of controlling entity, which here is called the lifecycle. It oversees the image creation and manages the build packs. The lifecycle tests groups of build packs against your app's source code. And if it finds a group that fits your source code, it will run these groups' actions and create an image from the output. And this happens then on top of a base runtime image, which in this case is Ubuntu. Several lifecycle interpretations exist. In the demo I will show you, we will use the pack command line interface, which uses Docker as a container runtime. There are several stages a build pack goes through during lifecycle execution. One major stage is the detect phase, in which build packs automatically detect whether they are required. For instance, here an npm build pack might look for a package JSON file, which then, if it exists, the build pack would say, yes, I'm part of this distribution. While, for example, a Go build pack might look for Go source files. Then the other major phase is the build phase, in which build packs do their actual jobs, for example, providing binaries or compiling source code. If you look at the Gramine build pack, it has a very simple detect phase. It just looks for a file called named app manifest in the root file, and this app manifest, we will see an example later. It's very similar to the Gramine manifest file. And then once it detects such a file, it will execute during the build stage. And what it does there, it basically just provides Gramine and its dependencies, like some pip packages. It will then go on and create and sign the manifest and set an entry point process, which is the process that basically starts the Graminized enclave. With this information, we are ready to take a look at the live demonstration. Let's see. Can you see my the terminal? Yes? Okay, great. So we'll start off by cloning a Git repository, the packet Buildpacks samples repository. And in that repository, we have lots of different examples how to build images from source code, mostly always with just one command with a pack command line interface. And what we want to look at now as an example is the Node.js yarn example. So that's we run a Node.js server and we use the yarn package manager to acquire our dependencies. And at the core is this very simple server application. It just starts an HTTP server on port 8080 and will provide this HTML file to whoever is contacting it. The other files is the package JSON file. It just describes the project. We have the yarn log file, which has basically just describes the dependencies, and we have the README, which gives us here this command. If we run this, we will build the Node.js application in one single command. But we want to add Gramine now. So let's to add Gramine, we first need to add the manifest file, which is this one. So it has a very simple configuration. We need to allow the event file descriptor system call, because otherwise Node.js didn't work for me. We have an enclave size of 1 GB, 16 threads. We add an environment variable to see some output from Node.js, and we have some trusted and allowed files. Now, as a next step, we're going to export the signing key into an environment variable. We just use base64 encoding to have one single string that we can put into an environment variable, and then we're ready. We can run the packed build command. This is the packed build command, and we have a few options here that I should explain. So, of course, we have the signing key. We need to sign the enclave. We have the Python PyCache prefix, and that basically says, Python, whenever you compile stuff, then please, or whenever you provide PyCache files, please put them into the temp folder, because those PyCache files, they're not deterministic. They include a timestamp, and we want to show the deterministic builds afterwards. That's why we add this environment variable. We have a few build packs, of course, Node.js, because it's a Node.js application. We have Python and pip, because they're Gramine dependencies, and we have the Gramine build pack itself. And the final option that we have is a clear cache. So we need to clear the cache whenever we run this this build command. If we wouldn't add that command, we would some stages, if it's supported, they would cache their layers. Like, for example, Node.js would cache its layer, providing all the binaries it has. Now, there is a specific situation where if it detects, if a build pack detects whether it has already some binaries or some applications in its cache, it might not provide them again in its layer. That means some files are missing when Gramine expands its manifest, like the trusted files. And also, these files then will be missing when Gramine runs. And if one of these files will be opened, it will fail because it's just not in a trusted files list. So that's why we need to clear the cache. So now we can run that build command, and let's have a look what it does. So it just basically pulls some images like the builder and the runtime image, and the build pack, the Node.js build pack, the Gramine build pack. And there we go. It goes into the detecting phase, like we discussed earlier. And these are the build packs that are eventually added then to the image. Now we go into the building stage. We have here Node.js, we have Yarn, Python, and pip is executed. And finally, we have the Gramine build pack starting, and it collects some pip packages, it generates the manifest, and it signs the manifest. And that's it. Now the application is, like the source code is converted to a Graminized container image. We can inspect that yarn sample image that we created. This is just like a bill of materials we have here. So we have information about the runtime image that is provided, and of course also the build packs and their specific versions. Now, finally, we have the different processes that are added to this runtime image. First is the web Gramine process. That's basically running Node.js in a Gramine environment. Bash Gramine is just basically a debug process where you are dropped into a bash shell inside Gramine, and web is the default, the previously default process which just starts Node.js without Gramine. Now we can go ahead and run it to verify if it is working. So it started up successfully, and we're exporting port 8080 to localhost, and the server is up. Now we can just curl localhost to verify that it's working, and yes, it's answering, and it's also writing down here that it received the request and answered it. And finally, let's have a look at the deterministic build property. So what we did here is we run the pack build command, and we saved it to an image called yarn sample. Let's change that image name to yarn sample verify. Now, if I execute this command, because we cleared the cache during executing, we're going to start completely from scratch. So it should build the exact same application, which does the same, and hopefully it also looks the same. And it actually does. So let's verify it. Let's run the yarn sample, which we previously built, and we see here the MR enclave hash. And next step, we want to run the verify version of that enclave, and it has the same exact MR enclave. So it's not a complete proof that the whole image looks the same. It's only, of course, the files that have been added to the manifest, but it's a nice way to show you that it's actually completely reproducible. Now let's head back to the presentation. Yeah, I think as it exists now, the Gramine Buildpack is already a great tool to facilitate the usage of Gramine. It provides a straightforward process for converting your source code to an SGX enclave. And even more, it has deterministic builds, and they come at no additional costs. And in trustless environments, this is a huge benefit. Integrity is the present owner of the Buildpack source code and wants to release it under a permissive or copyleft open source license. If that will not be the case, a rebuild from scratch could be an option. The project is, however, still in its infancy and will require further nurturing. So some things we can consider here, but it's not, of course, not all of the whole list. Code reviews would be nice. Implementing test cases is definitely something that needs to be done. And adding support for EPID and standalone decap drivers would also be something that would need to be added for a complete package. Because at the moment, we didn't bother with them. We just went straight for the entry kernel driver. Also, some thing to consider are limitations, and those limitations are due to Gramine security requirements. And for that reason, some stuff just doesn't work. Like, for example, the build cache, it will just not work. Like I showed you, it's because of those reasons, we cannot use build caching. The other thing that doesn't work is some build packs, by design, they will alter image state after the manifest has been signed. So we have the build stage, we have our full image, our full complete build image, and now we start it. And Buildpack has in its spec has this possibility to run scripts before the entry point of the actual application. And in these scripts, Buildpacks can do whatever they want. And they can also modify files which have been previously added to the manifest as trusted files with a specific hash. And if they are then opened by the SGX enclave, it will fail because the hash doesn't match. So that's there are some applications, some Buildpacks like PHP, for example, where I discovered that this just doesn't work. Yeah, all right, that's it. Thanks for allowing me to present this project to you. And yeah, are there any questions?
I have a question, but please let's go and start, Dimitri.
Yes. Yes. So if I would compare it to GSC, like there's one thing I think is very important is that it's much simpler. I think that's the thing that's most important, because with GSC you have quite a lot of commands you have to run through until you get your final image, and then also it only works with like your set of well, at least at the moment it only works with your set of Ubuntu images, and I think recently Red Hat images have been added as well. But yeah, I think there are different use cases. So for GSC, there is the use case where you have like a very custom application that you want to run, and you might invest time to really make it work exactly how you want it. But with the Gramine build pack, you have a very straightforward way for people who might not really be experienced in this kind of field, and they just need to provide their app manifest file, and then they can go and start run the application, build and run the application. And of course, deterministic builds you don't have with GSC.
Yeah, that's correct.
Exactly. Sorry. So in case like say for example you have a build pack that doesn't support reproducible builds, then that's not the case. Like Python, for example, if you have PyCache files running around your layers, then that's not deterministic. If you have I don't know, some Rust code or something like that, or C code that isn't configured to build deterministically, then the output will also not be deterministic. But with these limitations, like the build pack system itself will be reproducible as long as the underlying applications build reproducible binaries. Only the PyCache files I had to move to some specific point, and there was I actually used some scripts from GSC, and there was one situation where a dictionary which then generated the manifest file, it wasn't it kept on changing whenever you ran it. But if you sort that dictionary before you save it to a file, then it's also deterministic.
That's actually something we could fix in GSC itself, irrespective.
Yeah. Yeah. Yes. No. Sorry. Sorry. I confirmed understanding your question. I'll have to elaborate a bit more. So there's two ways how you get dependencies in your Buildpack environment. So one is at the base image, and that's you have a variety of different base images where you can choose from. The Gramine Buildpack currently only supports the cloud native Buildpack base images, which come in three different flavors. There's one very a tiny, I think it's called tiny base image, which has very few packages installed. It's like almost like the Ubuntu base image. Then you have a base base image which has a few dependencies, and then you have the full image which has lots of additional libraries and stuff installed via just the apt package manager. So that's one way to include dependencies. Of course, only if they're included in these base images. And the other possibility is, of course, by adding Buildpacks, existing Buildpacks, like for example, if you have a Go application, or if your application depends on some Go source code, you could just add that source code to your directory, and then it would that Buildpack would build from the source code. And the last option you have is you just build your custom Buildpack, which provides the dependencies that cannot be provided otherwise. Mm-hmm. Sure. So LKL, I think the idea is pretty nice because having the Linux kernel library means that you don't really have to invest much time in building your own system calls, etc. You just drop in the library, and then it's pretty nice that a lot of applications are just supported straight out of the box. But it seems like the project is in its infancy, and it has been discontinued already, because if you look at the project, there's no movement at all at the moment. And because I think it's in its infancy because the performance is really bad. We have to say that if you run your application, it maxes out the CPUs, and it's really slow. So this and some other properties, I don't know if we should go into detail here, led me to suggest Gramine to Integrity, to use Gramine as a libOS to Integrity. Yeah.
I have a question about the key management while signing the Buildpacks. I'm not familiar with this Buildpack technology, but as I understand it, you export it via environment variable, and it's accessible by all the Buildpacks and all the code that is inside those Buildpacks, right? So my question is, how do you manage that risk that some external dependency changes under you and just, I don't know, sends that key to somewhere else it shouldn't?
That's a valid point. I'm not aware of any kind of isolation between Buildpacks. So there's one possibility. Like the way I did it, I save the key in the environment variable, and yes, it's accessible by all other Buildpacks. The other approach that's possible is that you supply it as a volume, as a file in a volume which is attached to the build during the build, and I think you can define that volume as being for one specific Buildpack. But then again, I don't know if isolation then actually exists, or if another build pack could just mount that volume and look at it as well. So I'm not sure about that. But yeah, it's a valid point. You're right. If we don't know what kind of build packs we're running, we shouldn't give it the enclave signing key.
Yeah, I'm asking because I saw Node.js and NPM, and yeah, those ecosystems, as I understand, those have thousands of dependencies potentially, and that might explode. I'm asking also because we had a problem in one of the first iterations of GSC that the key was exported into the resulting image, and that I want to be extra safe about those keys.
Yes,
I can.
Yes, regarding this, we do
this is the solution.
in a separate container without networking. So we fork the container at some point, do the signing in one of them without connectivity, and just copy out the signatures. So even if you have something untrusted there, then you can do some damage, but you can't easily send out the key.
Mm-hmm. Yeah. I can assure that there's no that the signing key is not part of the image, because it's it will be submitted as a environment variable, but that environment variable is not part of the built image. Finally.
Yeah, but there's always a risk that some tool will, under the hood, just save some logs or dump
cache or whatever.
Cache or something.
Yeah,
so that's one of the risks if you use the key and then delete it from the image you want to ship. So that's why the image we are shipping in GSC never saw the key inside. It was a different image which did the signing.
Yeah.
Is that possible to configure in that Buildpack technology or not?
Well, I think looking at these arguments, probably the best way is to use a mounted volume. Then it's only a file that is present, but I don't know if it's possible to isolate volume access by Buildpack. So even then, there is the risk that another rogue Buildpack stumbles over this volume. So I don't think it's possible.
Yeah. Okay.
And by the way, regarding this, just to have an example, NPM was some packages, very popular packages in NPM was subverted multiple times. So this isn't.
That's
That's
right. But I think this is so. What happens in the build pack? Actually, just these packages are downloaded and extracted. So I'm not sure. I'm not expert on NPM or Yarn routines. There might be some per package routines which are executed after they have been extracted to configure themselves. So in that case, yes, we have a serious situation, because that code could then extract the key. That's true. But if that's not the case, if it's just extracting these files and there's no execution happening, it's just the npm executable downloading the files, then it looks a bit different. But I'm not arguing. So there is you're actually bringing up some really serious points here. That's true.
Another tangential topic about the signing is that there is also some architecture called two-step signing, that you first generate the measurement of the enclave and then export it to an entirely different machine, and the key never leaves that machine. Let's call it HSM or whatever, and only then there is the signature generated, and then manually copy it via some USB stick or whatever to the resulting, enclave.
Yes.
Is that possible with this Buildpack, or it would be hard?
Is it actually possible with Gramine? Because I looked at the,
Yes, it is. We have barely tooling. We have Python API for that, but no command line tools.
So the Gramine SGX sign tool supports this feature.
Python module. You can.
Okay. Because I actually looked at the SGX sign tool, and I didn't find this. I just saw that it basically just signs.
Because we don't have like native support for HSMs that you just point to an HSM, because there's no common interface for HSMs. So
I mean, there's PKCS, but yeah.
Yeah, like you will always need some intermediary code to for your specific HSM you use, and you plug this code to the Python API. That's the idea.
Well, there is like one way I could imagine this working is, and that would also solve the problem with the security of the signing key, is you can actually supply to the like I showed you, there are different processes that you can define when you run as a build pack, and then these processes you can later on run when you run the image. And so what you could do is you could instead of signing the image while during the build, you could provide another routine, another process which signs the image after it is built during runtime. So then you would add another layer of complexity, because you would build the image, then you would have to first run it and sign it, and then with that output you can start and run the actual enclave.
Yeah, that could work. Yeah, we probably would need to look closer at that.
Yeah,
but yeah, this looks promising.
Yeah. So usually Buildpacks are written in Go. Well, most of the ones I've saw from cloud native Buildpacks, they are written in Go, and there's under the hood they are using some libraries that have been written for that specific case. I went I took a different approach. I wrote it in Rust. There is also a library for that support that gives you almost the same features as the Go library in this regards. So it was quite easy to build, and there's not much source code. Let's say maybe 4 or 5 important files, and I forgot the rest of your question. Sorry. Yes, you said about the amount of work it took. So I can tell you that I think the implementation phase was like 1 or 2 months, but of course there was also some planning phase involved, like about 1 month. So that's what it took about.
Just one question on the manifest, right? The app.manifest, does the build pack actually? So is that the actual manifest that is getting used, or does the build pack generate a final manifest just the way how we do with GSC?
It's like that. It's like the second one. It modifies this app.manifest that is provided by the user in a few ways. Like, for example, Maybe I can even show you. So this is, you see the terminal, right?
Yeah.
So like in a Buildpack image, you have the layers directory, and in that layers directory, different Buildpacks can store their binaries, etc. And what the Gramine Buildpack does, it basically scans that directory and checks what Buildpacks will be there at runtime, and then it automatically adds these folders to the trusted files as a convenience for the user.
Okay, so this plus whatever is there in the app.manifest put together be the final manifest, right?
Yeah, and I think also, yes, even more. I think, yeah, as you saw, that like the app.manifest, it's quite slim. You need to still configure the entry points and stuff like that. That's also from the top of my head, I can't tell you all of it right now.
Yeah. Okay.
If you want to, I can show you, but it's up to you.
No, that's okay. Yeah.
Okay. All right.
And what is the final size of the image? I mean, generally, have you seen with and without Gramine? How do they look like, right?
Oh, sorry.
Yeah, exactly where I was going. Yeah.
Okay. What do you want to see? The manifest files or the Docker image?
Final manifest. Yeah.
Okay. So it's 2.7 megabytes.
That's okay.
In this case.
Yep. In this case, yeah. Okay.
You want to also see we can also run the build again without Gramine and see how big the image container image is in total if you want to, but I don't think there's going to be a big difference. Well, there might be because you add Python and everything.
Okay. Yeah, I think that's all I had. Yeah.
Last question. Do you think there is something that should be changes in the Gramine project itself to accommodate some, I don't know, possible future directions? Or
Very good question. So I think my personal opinion is also for the GSC project, Python is a huge blocker. Like there's I already submitted one pull request to the Gramine project, which at least for the decap driver removes the necessity to have what is it? Exactly, the token files. So you can remove the Python dependency from the runtime image completely with that. The other thing then is the signing routine, which is still written in Python. And I just had an investigative look at the SDK, Intel SDK, and there's already a C program which does the signing, and it also supports separate signing, like we just discussed. I don't know if it's applicable to the Gramine project, but that if that's the case, it would be pretty easy to remove Python from this, like the Python dependency from this aspect as well. And once we have that, I don't like in the Gramine Buildpack wouldn't need Python at all, and also not pip. And in addition, GSC as well. So, well, we could head towards even merging both projects in a way that you could just use Buildpacks how you always do, and then you have the GSC routine, which converts your Buildpack image to a Graminized build. But I think what we need for that is that we remove dependencies to such an extent that the only thing that's left to do is you copy the Gramine binaries into the image, and then you create and sign the manifest, and that's it. No additional dependencies. And that way you can also, you have stuff like you can have images which are not run as the root user. That's a limitation for GSC at the moment, and probably most other distributions, Linux distributions, would be able to work out of the box.
Yeah, thank you. Yeah, but the token is a real issue. Signing maybe not that much, because it just needs to be done once in the package lifecycle, and then it's deployed, and yeah, we should think about that.
Well, there's like, I've worked on .NET applications, so there I had to submit a few patches, but then now it's working. The other thing, it was a lot of fun, and the other thing well, it will probably involve a lot of reworking, but what I would like to see, and what would make a user's life much more easier, is if you can have a trusted file that can be edited and like converted to a protected file. That would be something nice. So, like, for example, you have a trusted file, it has a hash, it's in the manifest, the enclave starts, and then there's some modification by the enclave itself in the enclave of that trusted file. So it will basically be converted to a protected file, which is encrypted by either a key or the MR signer sealing key or stuff like that. And then the next time the enclave is started, it would see automatically, okay, this is not a trusted file anymore, but I'm not going to fail because it's a protected file and I can decrypt it.
Well, one problem is that it would need to be a separate file, because you can't tell if it's like trusted file with protected file header or protected file, which you need to parse.
Okay. Or you have a you would upon first starting the enclave, you would have like open a protected file, which is basically has an index of files that have been modified. That's also something could be possible. But yeah.
Yeah.
And there was one other thing, but we're already almost at the end of the meeting. I opened a ticket, which is also actually about files. It's about the expanding files and about the order of allowed, trusted, and protected files. Like if you have a file which is in multiple of these lists, what happens then? There's no documentation, I think, about it, and I think it's important for specific use cases.
So we are already fixing this. Take a look at the most recent issue about protected files and pull requests for mount points from Paape.
Okay. Oh, wow, that's really nice. Okay, I hopefully I will find that. Otherwise, I'm just going to ask for the link. I could what I'm interested in is with Gramine is that there's lots I'm interested in, but what comes to my head right now is also part of the company that I found it is to make Gramine deterministically built. And that way I can check off another one of the requirements that the company has, because in the end I want to provide services that, like I told earlier, you would be able to completely verify the whole application down to the source code, that it does exactly what it does, and it's from you have an MRI enclave hash, and from there you can completely track and audit the application. That's something I would like to reach. So
regarding this, we have an issue about reproducible builds. Could you mention your solution? Is it already open sourced somewhere or not yet?
I didn't understand the question. Could you repeat?
We have an issue about reproducible builds.
Yes.
So could you mention your solution there? Is it open source anywhere already, or
there's no work. Maybe I said something in a wrong way, but I haven't worked on that yet. So that would be that's on my to-do list. That's something I would like to work on.
Okay, I thought it's already done.
No, not yet.
I see.
Yes, exactly. That's the case.
I see. Okay.
But we already have signed binaries by the project, so that's already a great step. And a year ago that wasn't. So I think it's great. So it wouldn't be on my top priority, but it's something that should be done sooner than later. I like to take the last moment to also thank Invisible Things Lab. I'm just running this presentation on cubes, which I'm using for almost I don't know 4 or 5 years. It's the best OS I've ever used. So thanks a lot.
Thank you.
Thanks.
Great. Thanks.
Yeah, and
Thanks for having
the
me.
invitation for the weekly meeting is standing. Anytime you'd like to join to discuss something, please join.
Okay. Thanks.